All right, guys. Here we go with base metal prep, module 5, session 2. Okay. When you complete this session, you should be able to identify and describe basic weld joint design and types of welds, and describe how to prepare joints for welding. Okay. All right, joint design. Any or all of these forces can act upon a weld and cause failure. During testing, under these loads, good welds often outperform the base metal. And as we'll learn when we get into the shielded metal arc welding sections, that's mainly because a lot of your arc weld, your welding material has a higher tensile strength than your base metal does. So yes, when they are put in properly, a lot of times when there is a failure, there'll actually be a tearing of base metal and not a breaking of weld. Okay, so some of the different forces, if we look starting left to right, tension. Basically, tension is a pulling force. Okay, think of it like a tug of war. You have force 1 pulling against force 2. Compression, now instead of them fighting against each other, they're pushing towards each other. Bending, so in a bending stress, you have a force holding either end of a member, and then a force put in the middle of the member in the opposite direction. Torsion is a twisting force, and shear would be, as shown on the far right there, you have two forces acting in opposite directions on either side of the weld. Okay, basic joint types. Okay, so starting at the top, butt joint, this is where two plates are just butted together. Corner joints, lap joints, and T-joints all actually end up having fillet welds for the most part. And so it's just kind of the arrangement of the different materials there. As you can see, the corner is two edges that are welded together. A lap is two plates that are laid on top of each other. A T-joint is just what it says. It's the shape of a T. Flanged lap joints, flanged corner joints, an edge joint. So what the edge joint is, when you have the two plate edges next to each other, it's the weld that would be performed to stick those two plates together. A flanged butt joint. So now what you've done is these two plates have a bend in them where they come together in kind of an edge joint. It becomes a flanged butt joint. We have a flanged T-joint and a flanged edge joint. Okay, guys, there's a lot of different joint design here, and what we're going to work with mainly is T-joints and sort of a butt joint. So, know what these other joints are, but we probably won't be using them in the shop. Okay, surface welding. Surface welding is not used to join components. Building pads during future welding practices equates to surface welding. So yeah, when we start welding, guys, you guys will start doing bead pads, and basically that's just a surface weld. A lot of times this is used either with a high alloy rod that has good wear characteristics, and it's done over the top of wear parts that are going to contact soil, so it increases the life of those parts. Also, sometimes it's done on parts that are worn down to build them back up to the thickness they need to be. Plug or slot welding. These are just basically welds that are done kind of in two plates or two members that are basically laid on top of each other and need to be welded, kind of in spots where you can't really do an edge or a corner weld. And so you have a plug weld is basically just a hole in one plate that's laid over the top of another, and then it's welded up. And a slot weld, now instead of just a round hole, it's a slot. It's a rounded slot that's welded up. Okay, fillet welds. Fillet welds can be applied to lap joints, T-joints, or corner joints. No root opening exists. Okay, and if you notice here, we're not to weld symbols yet, but pay special attention here. This is kind of our first look at it. So the weld symbol is there. It's the arrow with the little triangle on it. And a couple things to note where it's showing us arrow side. The bottom of the line is always arrow side, regardless of where the line is placed or what direction the arrow is going. The top of the line is always going to be other side, so that's going to be opposite where the arrow is pointing. And if it's top and bottom, it'll be on both sides. Okay, so in the fillet weld is done on a T-joint, like it says T-joint, lap joint, or corner joint. And basically it's that little triangular weld that's being laid down there. It's a kind of in a darker gray on these images. Okay, fit up of half lap fillet welds. Half lap joints are much better alternative to corner joints. Although a second weld must be placed on the backside, the half lap prevents burning through the fragile edge of the workpiece. Okay, beveled groove welds. Okay, so we'll do these as part of our certification practice. They're single bevel joints that are easy to prepare. They can be applied to all 5 basic weld joint design. The other thing is this is done when you're welding thicker sections, and so then you're making multiple passes to ensure proper fusion between the 2 plates. Okay, a V-groove bevel weld. Okay, so this is what we're looking at here. This is similar to what we do for the weld test. What's shown here is actually an open root V-groove. These are practice plates that we'll do in preparation for pipe, but you will see these again. When it's open root, it's typically a 30-degree bevel, which gives you a complete groove angle of 60 degrees. The size of any root face required must be considered as the bevels are created. So if we look there, there's a root face in the joint details down to the bottom right there. When we get to the point of putting these together, I will give you guys, I'll demonstrate for you guys prior to just throwing you out there to do it. Okay, single versus double V-groove welds. Believe it or not, the double V-groove weld requires less weld material to fill than the single V-groove weld. So as you can see in the illustration, welding the same thickness of material, but doing it with fewer welds. Okay, J and U groove joints. J and U groove joints require a significant amount of preparation due to their odd shape of their groove. Okay, groove angles and root openings. The size of the root opening in a weld is critical to building an acceptable weld. Okay, there are limitations on what your minimums and your maximums are when you look at a procedure, and then there's also a little bit of personal preference. So for instance, when I do an open root V-groove like this or an open root pipe weld, I prefer a land or root face of 3/32 of an inch and a root opening of 3/32. I've had some students that go as narrow as like a 1/16 of an inch on both. I have some students that go clear to the full 1/8 inch that's allowed by the code. So a lot of it becomes personal preference, but also too, depending on what rod diameter you're using, can also dictate what root opening you need. All right, open root welds. Note the groove angles on pipe and plate vary. Remember that you do not choose these characteristics that are specified. So yes, these will be listed on your WPS, your weld procedure. Okay, this is a WPS. Think of a WPS as an instruction manual for how you're going to complete the weld so that it meets specifications and meets the strength requirements. So this is just a basic WPS. You guys will also see the ones that West Hills College has. Okay, mechanical joint preparation. Welders become proficient with a handheld grinder after a number of weld joints have been prepared in this traditional way. Okay, this can be time consuming, but a lot of times it's faster than some of your other options. All right, pipe can be beveled by hand. The productivity often requires special equipment that works quickly, provides a better surface, and maintains a precise bevel angle. Okay, thermal joint preparation. Track burners do an excellent job of beveling, much smoother and more consistent than handheld oxy-fuel torches. Okay, cutting and beveling pipe can be done effectively using portable equipment like this. This equipment can be automated or hand-driven. All right. All right, guys, remember, complete the review questions, the review quiz, as well as the trade terms quiz and prep for the module exam.